recording. Okay, on to the beginning. Here we go. So, general overview, intro to rocketry avionics track. We're going to be exploring and learning about electronics and software that controls and monitors the flights of our rockets. So, anything that's electronic or software related that goes in a rocket, we'll be talking about and discussing. So, some of this general ideas we're going to go over: Arduinos and Arduino software programming, which some people already have a bunch of experience in. We're going to work on like some sensors and how you interface with sensors and how you tell how to read data from a sensor. We'll do some electronic circuit design, which leads into PCB design, which seems like there's a lot of interest in that. We'll talk about some other interesting topics, such as like memory modules, radio, and then hopefully some Linux as well. So that's a general overview. Here we have a picture of a board that you'll learn a little bit more about later in the slideshow. So general project structure. First couple weeks is going to be soldering and assembly of the Arduino boards. So that's the soldering of the Arduino boards, making sure that your board works and that you can program it and that it's not messed up. And then we're going to go through some of the skills using the Arduino board, such as like writing programs to make the Arduino do things, control LEDs, read buttons, and then read sensors. And then the last few weeks of the track, we're going to be going over some cool, interesting topics and discussing those and hopefully working on some more projects with those things. And then beyond all of this, towards the end in those extra projects, we'll kind of divide out into groups and figure out where people want to move forward. So whether that's going into PCB design or software development or like high-level computer vision, machine learning software. So low-level software that will break out into different groups so that people can focus on what they like after they've kind of seen the different areas that we have. And those groups will work directly with the other projects in Aero and you. So starting out, Arduino project that we're all going to start with. So we have a custom PCB that John has designed over the summer and has built. So that is actually built now. That's pretty cool. So starting with that is going to be a bunch of soldering. So we were going to be sending everybody equipment for soldering these boards. So get a board, a bunch of little components that go into it, some solder, some safety equipment, and a soldering iron. Luckily, a couple people had soldering irons, which is really useful for me because I only have 20 soldering irons. Writing programs to control the LEDs. So that's with those Arduinos to make sure they work. We're going to flash some LEDs and then move on to more complicated operations with them. What's an Arduino? So it's a printed circuit board. So it's a PCB, which I'm sure you guys have seen PCBs before, but it's like the little green boards that a lot of electronics are built out of, with a microcontroller. So if you look at the little picture I have here, number 1 is the microcontroller. So in this case, it's an embedded device, so it has memory on board, so the programs are on board, as well as the actual processing is on board as well. And then it also has I/O, so input and output devices. So that's, if you look at number 2 on the picture, is the header pins. So that's how you connect wires to the Arduino. Or if you look at number 4 is the LEDs, which is which is little lights that light up. Also the USB port, so that's how we write code to the Arduino and then like read some data back from it. Goes through there. 5 is the button, so that's another I/O. You press it. And number 6 is the voltage regulator. So that is what provides the right power to the board. So that's part of more PCB design. You'll discuss like, oh, what kind of regulator do I use and where? So now, comparing this to what we actually use in the project for the real flight electronics that we use every day in Aero and you. So shown here is the board that Ben designed. It's the main flight control board for Redshift. So it has the same kind of things. So if you look around the board, I kind of match the numbers up to generally what the other ones are. So there's like a USB port. there's no button, but there's little jumper pins that you can control for interface. You have a bunch of terminal blocks, which are just like the little pins that you could plug into the Arduino. You have a microcontroller, same thing, another like a processor, the brain of the computer board. You have some LEDs. Then you also have some other fun things on here, like you have a GPS module, which I think you can see my mouse, GPS module. And then we also have some radio circuitry. So it has this board around it to protect the radio from the other parts, the other electronics interference on the board. So that's pretty cool. So the reason why we start with Arduino is it's a nice introduction to what we're doing in the more advanced projects. It's a version of C, so it's a little bit easier to learn and less powerful, but it helps you get onto the track that you need to write the code for these boards. And the same thing is of looking at the circuit board and seeing how the devices work helps you learn how to go forward and design your own circuit boards. So then looking at some of the advanced topics we'll talk about, some of these will be more interspersed throughout the track, like circuit and PCB design. We'll talk about little aspects of that throughout the different sessions we're going to have every week. And then the other ones will be more like special topics that we'll talk about at one point, hopefully get to explore some. Meeting structure. So this is how we're planning on having each of these meetings be. So we'll start out with a 20 to 30-minute presentation. So kind of like this. In more detail, we'll go into like talking about like how things work and what they're doing and how we use them. And then we'll have work time where we'll either all be in one group in the chat or we'll break out into smaller groups with different mentors and we'll work on a task. So we have a task for today that we'll talk about at the end. Yeah, and you have the rest of the time to work on it. And that's the best way to learn is by doing. Oh, I guess this was shorter than I thought. Okay, so we are going to stop recording.